in today's video, we're going to be solving the problem minimum platforms. So, the question over here says that given the arrival and departure times of all trains that reach a railway station, find the minimum number of platforms required for the railway station so that no train is kept waiting. Consider that all the trains that arrive on the same day and leave on the same day. Arrival and departure time can never be the same for a train, but we can have the arrival time of one train equal to the departure time of the other. At any given instance of time, same platform cannot be used for both departure of a train and arrival of another train. Okay. In the such cases, we need different platforms. Okay. So when we are given a question like this, it's written that so basically what the question is saying is that when you have trains coming in and going out from a train station, right? And all of them are going to come in and leave on the same day, right? Now you have the arrival time and the departure time of the trains given to you. So one train might arrive at 900, 9 o'clock, and it might leave at 9:10 p.m. or a.m. Another train might arrive at 9:40 and it might leave at 12. One train might arrive at 9:50 and it leave at 11:20. Okay. But what it says is that no two trains can come on the same time, which means that if this train is coming at 9:10, is departing at 9:10, leaving the station 9:10, this train can come at 9:40 because the train station would be empty at that point, right? But over here, when if this train is arriving at 9:40 and it's gonna stay at the station till 10 o'clock, right? So the third train which comes at 9:50 cannot come at that platform because the platform is already occupied by the second train. So for this train, you need a second platform. So this train needs to go to a different platform, right? It says the exact same thing over here. Now, when this train comes at the comes at the second platform, we see that it leaves at 11:20. So which leaves us, occupied with just one platform, which is this one at that same time. Because because it's going to stay there at 12 o'clock and this one is going to leave at 11:20. So let's just take a dry run of this. So when we have this example, okay, let's take the whole thing. And so when we have both these things over here, right, now if the train arrives at let's say platform, let's say we have one platform number one, right? At platform number one, this train is arriving at 9 p.m. and it's going to leave at 9:10. Okay, and this, let's say we have total equal to total number of platforms, which is currently also equal to one. So the platform number one is going to have the train at index number one. Okay, so let's just write it like this: index one. We'll have the train at index number one. But you can also see that the index number one platform train is going to leave at 9:10, which means it's going to leave in 10 minutes. So, which means that there is no train occupied right now. It also leaves before this train arrives. The second train arrives, which means that there is no train currently at any platform. When the second train comes, this train can occupy the very first platform itself because there's no train on any platform right now. So the total number of occupied platforms is again going to be only one. Now, since this train is going to stay at the platform till 12 p.m., right, or 12 o'clock, the third train which comes at 9:50 cannot go at this platform because there is already one train occupied. So it needs to go at platform number two, right? So platform number two will have the train at index number three, and we'll have total of two platforms being used right now, right? Now, since this is already being used, but you can also see that this train leaves at 11:20. Okay, it leaves at 11:20, but the fourth train which arrives is going to arrive at 11 o'clock. Okay, so there's already a train occupied over here at 12 o'clock till 12 o'clock and one train till 11:20. So the fourth train which comes needs to occupy a fourth platform, a third platform, which will have which will occupy the train at index 4, and will have a total of three platforms being occupied right now. All right. Now, this train leaves at 11:30, and by the time this train leaves, this train would already be having left its platform. So right now we would have these two platforms empty, completely empty, right? And by the time the fifth train comes, all the platforms would have been empty right now because this leaves at 12 o'clock and this is coming at 15. So all the platforms might be empty right now. Okay. When this train comes, it'll then go to in platform number one, and we'll have a total of one platform being used right now, and it's going to stay there at 19. And this last train, which comes at 18, will obviously occupy the second platform because the fifth train is already at platform number one. So we have a total of two platforms being used right now. Right. So you need to tell how many minimum platforms are in total needed. As you saw earlier, we needed a maximum of three platforms over here when we were at these three positions, at these three indexes, right? So that is what the answer is going to be. You need a minimum of three platforms, which is going to occupy all these trains' arrival and departure times, right? So this is what the question is. Okay. Now, if you think about it, it hasn't mentioned whether all the arrival and departure times of the trains are in a sorted manner or not. This question is already given in a sorted manner, but in the interviews, it's not going to be given you. It's not going to be given to you in a sorted manner. Okay, so let's just take an example where it's not in a sorted manner, like over here. Okay, so right now it's given it to you in a non-sorted manner. Now, how are you going to solve this problem? Okay, the main gist of how you have to solve this problem is behind sorting both the arrays. You need to sort the arrays in terms of the arrival time and in terms of the departure time. Now you'll probably have a question in your head that if we do sort them right individually, won't the indexes get mixed up? Like over here, the train which arrives at 120 has a departure time of 600, but over here that same train has a departure time of 550. Right? It is the index is going to get mixed up. But what you need to know is you don't need to worry about them getting mixed up. You just need to keep a focus. You just need to keep in mind what time the train is arriving and what time the train is departing. Let's do it right in for you so that you can get in your head of what we're going to do over here. Okay. So what we're going to do in this question is basically we'll keep two pointers. Okay. Let's say we have a pointer I and we have a pointer J. Okay. Now what these two pointers are going to do is are right now a current time over here is this, make it like this. I is equal to 0 and J is equal to 1. Okay. So let's just make this J and make this I because I already solved the problem in that manner. So let's make this J and make this I. Why we're making this J equal to 1 over here and not 0? Because already one platform is going to be used by one train which is arriving at the arrival time of 50. So one platform is already being used. And since one platform is already being used, which is going to keep a max counter, which is going to signify total number of platforms that were used, total maximum number of platforms that were used. Okay, right now. Okay, so since that's the case, right, we already have one platform being used when we have a train arriving at 50. Okay, since one train is arriving at 50, we already have one platform being used, and we're going to just keep a platform count to one and a max count to one. Now, what we're going to do is we're going to check if the time of this train when it arrives, right, is greater than or lesser than the departure time of this array's very first element. So it shows that the departure time, the smallest departure time that you're going to get for any train, if the least amount of time that any train can departure at from among all these trains is at 500, right? So obviously, if you think about it logically, if this train comes at 120, it doesn't matter. You'll probably need to take an extra platform, anyways. Whether because the most minimum time any train can leave is at 500, so you will need an extra platform. Right. Since this train is arriving at 120. Now, since this train is arriving at 120, you will need an extra platform because it is lesser than the departure time, the most minimum departure time. So, you need one more platform, and the max counter of platforms is going to be two. Now, since this is great done, you need to increment the counter of J to check for the very third arrival time train. Now, the third arrival time of train is 200, which is again less than the most minimum departure time, which means that you will need one more platform over here. Since you'll need one more platform, we're just going to make this a 3 and a max counter equal to 3 and a J which was 1, now 2, will become 3 when we increment it to go over here. Okay. Now, when we have 550, right, we see that this arrival time is greater than the most minimum departure time. Since it is greater than the most minimum departure time, we don't need an extra platform for this, which means that we will probably just reduce the number of platforms we have when we go over here, right, which will make it equal to 2. Okay. And we'll just increment this I to 550. Okay, now why are we decrementing the platforms counter to 2? Because since these three trains have a arrival time lesser than the most minimum departure time, we need its individual platforms for them. But for 550, what's going to happen is one platform, at least one platform, is going to get empty by the time, because there is one departure time. Great, it's greater than one of the departure times, right? So we probably will have one, platform empty during the time this train comes. So we don't need to increment the counter, we just need to decrement it to show that, you know there will be a platform empty during this time. Okay. Now, when we come at 550, right, over here it also says that at any given instance of time, same platform cannot be used for both departure time of a train and arrival time of a train. So here, both departure time and arrival time is same, which means that we cannot use the same platform for this. Since we cannot use the same platform for this, we'll need to increment the number of platforms we need to 3. And the max counter at when we had 2 will also be 3, because that is the maximum number of platforms we're going to need. Right. And in this case, we can increment j to over here. And when we increment j, we'll make it to the pointer 4. Now, when we make it to reach pointer 4, we're going to check again for 550 and 700. Now, our departure time is less than our arrival time. Since it is lesser, we're just going to increment this and reduce the number of platforms over here. Since we reduce the number of platforms over here, we're just going to make this a 2. Okay, we're going to reduce the number of platforms over here, which basically just signifies that there will be a platform available when this train arrives. So we don't need to, we don't need an extra platform for this. We can just reduce the number of platforms, which will just signify that we have extra space for this train. Already, will probably just have an extra space for this train. Again, when we have 700 and 600 now, when we have 700 and 600, we'll just increment I again, will reduce platforms by 1, and max is still going to be 3, and this is going to become 3. Right? It's the same logic over here, that since the departure time is lesser than the arrival time, which means that there will be a platform empty for us. Okay. Now, when we have both our arrival and departure time equal to the same element, when these both are same, we will need an extra platform. And when we need extra platform, we just increment j to go to 5. Now, when j goes to 5, we come over here. Now, here we see that 850 is greater than 900, 700, which means that the number of platforms, there will be an empty platform for us. So then we'll just reduce the number of platforms by -1. Okay, and we'll just increment I over here. And when we increment I over here, we go to 900, and we see that the arrival time is lesser than the departure time, which means that when arrival time is lesser than departure time, which means that we will need an extra platform for this train. We'll just increment this by 2. And this loop is, and we'll just make this 6. And this loop is only going to run until all the arrival times of the train is complete. When all the arrival times of the train are complete, we can see that the max is 3, which means that all the trains can arrive to the train station within 3 platforms, maximum of 3 platforms. Okay, so guys, this is what the logic of the question is. Okay, I hope you understand why we sorted both the arrays and array arrival and departure times, because we don't need both of them in the same sequence. Like, we don't need 120 and 600 in the same line just to get the answer. We don't need the same indexes for them. We just need to use the logic of the train arrival and departure time, like I showed you right now, so that we can get the answer. Okay, so now let's code the solution out. So to code the solution, let's first just sort both the arrays. Array.sort and dp departure.sort. And we'll just keep a platform counter equal to 1 and a max counter equal to, a max counter equal to 1. Now we'll keep our I pointer equal to 0 and our j pointer equal to 1. And we'll just loop through it while a j is less than length of arrival. Okay. Now, if our departure time of I is greater than or equal to arrival time of j, then we just do a PLT, platform plus equal 1. We'll check for our max equal to max of max comma PLT, and we'll just increment j by 1. Else, what we'll do is we'll just increment I by 1 and reduce the number of platforms by 1. And in the end, we'll just return max. Okay, so let's just run the code, guys. Yeah, it's running. And let's just submit this. Yeah, it's submitted. Okay, guys, so this is what the question was, and this is what the code is. And if you like the video, do like, share, and subscribe. Do let me in the comments if you have any doubts or if you have any suggestions for new video ideas or any new lead code coding questions or Geeks for Geeks coding questions. Do check out my podcast. And until next time, see you guys.